Okay, hello once again. Coming towards the end of chapter 1, permutations and combinations is the topic for today's lesson. It's going to be really important you have a GDC for the lesson because we're going to need, I want to be able to teach you how to do this on the calculator as well. We'll do that in class when everyone's got their calculator in front of them. But today I'm going to focus on the maths behind it. And it's all about how to choose different numbers of objects in various different situations. So we'll start with the simplest situation, which is where we've got an infinite supply of something, or as many as we need. So let's say I'm going to make a 4-letter word using the letters A, B, C, and D. I've got as many of those as I want. Well, I could start, my first word I would make would be A. 4 A's. And then A, B, A, C. And then the last one would be D. So hopefully it's reasonably obvious to see that there's a choice of 4 letters for the A, for the first letter, choice of 4 for the second, A, B, C, or D, choice of 4 here, and a choice of 4 here, for a total, all the options of 256 different letters, different words. That should be familiar. What if my A, B, C, and D are finite? I've only got one of them. So this is called a permutation. How many different ways are there to arrange the letters A, B, C, D? Well, there's the obvious, the first one, A, B, C, D, like I've written there. And then the next one, I guess, let's just improve that. The next one, I guess, would be A, B, B, C. And then the next one would be, well, I've done all the A, B's, so it would be A, C, B, D. That would be the next one. And the next one would be A, C, D, B, like that, and so on and so on and so on. How many different ways are there to do that without having to work them all out? Well, it's similar to what we had before, because there's still 4 possibilities for the first letter. But the second letter, there's only 3, because you've used one of them here. By the time you get to the third letter, there's only 2 possibilities. And by the time you get to the last letter, just 1. So if we're putting n objects, well, in this case it's 4 objects, so it's 4 times 3 times 2 times 1, which is 24. But in general, if it's n objects, for n objects, then that number is n times n minus 1 times n minus 2, just counting down until you get to 1. And that number has a name. It's called n factorial. It's written with an exclamation mark. N factorial. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And if you had 6 objects, then there would be that many ways. It's quite a big number. What would it be? 24 times 30, 240 times 3, 720. And obviously that number gets big really fast. 12 factorial will be a really big number. And your calculator probably can't do, I don't know, maybe more than 100 factorial or something like that. So, one other thing I suppose is worth mentioning is, what if you had no objects? How many ways are there to order no objects? Well, there's still one way to do it. I'll put nothing. So, although it might seem counterintuitive, 0 factorial, we define it as equal to 1. We can do that. Factorial is a function that mathematicians have invented. So if I want to say 0 factorial is equal to 1, who's to stop me? And that's what we say. The factorial function is only defined on 0, 1, and the other positive integers. So you can't do negative something factorial. You can't do 2.5 factorial. And if you try to do that in a calculator, you'll see that you get an error. It's not defined there. Okay. Slightly more complex. What if you don't pick all the objects? What if I'm still making a 4-letter word, but now I've got 8 letters to pick from? Well, it's obviously not going to be 8 factorial. That's going to be too many. 8 factorial is going to be too big. Because I'm only looking at really the first 4 letters in that word. I'm not looking at the whole 8 spaces. I'm just looking at the first 4. Quite interesting then. So we can work it out by saying, well, there's still a choice of 8 there, still a choice of 7 there, still a choice of 6 there, and still a choice of 5 there. Multiply them together. So this one could be A, B, C, D, E, F, G, or H. But this one we've already used 1 letter. This one we've now used 2, and by the time we get to there, we've used 3. So that's 8 times 7 times 6 times 5, which is 442 times 40, which is 1,680. 42 times 40. I'm just going to check that. Yeah, 1,680. Okay. So how could we write that? We can't write n factorial. If I've got n objects and I'm only permuting r of them. I'm going to permute r of them. What's meant to say then? Well, there's a way to write this. It's written as NPR. Not the public broadcaster in the United States of America, but how many permutations of R objects are there out of n? And the answer is it's n factorial divided by n minus r factorial. So in the example above, there were 8 objects, 8 factorial, but we were only looking for 4 of them. So 8 minus 4 factorial goes in the denominator. And if you write that out longhand, that's 8 factorial on the top, and on the bottom, 8 minus 4 factorial. Well, that's just 4 factorial, because 8 minus 4 is 4, so that's 4 times 3 times 2 times 1. And you'll see that these all cancel. And we're left with 1,680, the same number we had here. 8 times 7 times 6 times 5. So the n minus r factorial on the bottom, what you're doing there is you're dividing out all the combinations that come after. So in our 8, if I had all 8 letters and I put them in permutations, I get 8 factorial. It's a big number. But a lot of them would be the same, because I'm only looking at the first 4 letters. So how many repeats would I get each time? How many repeats would I get? Well, how many ways are there to put 4 letters in there? So for every 4 letters I got here, A, B, C, D, I'd have 4 letters that I wasn't using, E, F, G, and H. But it wouldn't have to be E, F, G, and H. It could be E, F, H, and G. And I'd still have A, B, C, D in that order that I'm using. Or it could be E, G, F, H. And how many different ways are there to do that? All corresponds to the same four-letter words. Oh, there's 4 factorial ways to organize those letters. So that's why it becomes 8 factorial over 4 factorial. Because 8 factorial would be if we were arranging all 8 letters, but I'm only interested in the first 4, so I have to divide by the 4 factorial that's left. If we were picking, if we had 6 letters, I was making a 4-letter word, it'd be 6 factorial over 2 factorial. Okay. I'm going to skip that bit. So the last thing I'm going to talk about is the combinations. How many different combinations? So now we don't care about the order. So let's say I've got 6 objects and I want to choose 3 of them. How many ways are there to do that? Well, I could choose A, B, and C. I could choose A, B, and D. I could choose A, B, and E, and so on. But what I wouldn't choose is I wouldn't choose C, A, and B because they'd be the same. I've chosen the same 3 letters because I don't care about the order. I wouldn't choose B, D, and A. So how do I edit my permutations formula? N factorial over n minus r factorial to give me a combinations formula. N factorial. So there's something we have to add to this formula to make sense for combinations. And it's just how many repeats do we have? Well, let's say I'm doing 6, choose 6, choose 4. So I know that there's 6 over 4 factorial, 6 factorial over 4 factorial ways of getting those permutations, but I don't care about the order. You know, I don't care if ABCD is different to DCBA. So how many times is it repeated? How many times would ABCD be repeated in our permutations? Well, it's the same thing as asking how many permutations would there be of those 4 letters. So for ABCD, there'd be ABCD, ABDC, ACBD, and so on. How many combinations? Well, we've already seen that. We know it's 4 factorial repeats. If this is R, then it's R repeats, and we want to get rid of them. So I need to get rid of all those repeats by dividing by them. So the combinations formula is not n factorial over n minus r factorial, it's n factorial over r factorial, n minus r factorial. Let's do a quick example. If I'm doing 6 letters, choosing 4, how many ways are to do that? 6 choose 4 is equal to 6 factorial over 4 factorial times 2 factorial. This bit is our permutations formula. And this bit is every repeat of the same combination that we're not counting. So all these repeats here. And we could work out what that is if I write it out longhand. So there's 2 factorial there, there's 4 factorial there, and there's 6 factorial on the top. Now a lot of these things are going to cancel. They all cancel. I'm left with 6 times 5 over 2 times 1, which is 30 over 2, which is 15. So if I've got 6 objects and I pick 4 of them, there's 15 ways to do that. going to do a very quick problem because I've been talking for a long time. So I've got 14 pupils. How many ways are there to choose 4 from 14? Well, 4 choose 14. So 14 choose 4. 14 choose 4 is 14 factorial over 10 factorial times 4 factorial from our formula from before. N factorial on top, 10 factorial, 4 factorial, these two numbers will always add up to 14. Well, it will always add up to that number, and one of them is going to be that, which is the same as 14 times 13 times 12 times 11. Everything after that, the 10 is going to cancel with the 10 factorial over 4 factorial. And you can always, like I said, we'll go through how to do this on a calculator, but you can always simplify this. So there's a 6 there, cancel that with 2, 2 there, and another 2 there. We're left with 7 times 13 times 11, which, as everyone knows, is 1001. There are 1001 different ways to pick 4 out of you lot to go represent at the maths competition. But what if I have to send 2 boys and 2 girls? Well, the girls are easy. There's 3 of them, and I've got to choose 2. That's 3 factorial over 2 factorial, 1 factorial, which is just 3. Instead of choosing 2, I can choose 1 to leave behind. How many ways are there to choose 1 girl to leave behind? Well, I can choose Hillary, or I can choose Rosa, or I can choose Marta. So there's 3 ways to do that. 11 boys, it's less intuitive, but the process is the same. How many ways are there to choose 2 boys? 11 choose 2, 11 factorial over 2 factorial, 9 factorial. That's 55. So how many ways are there to choose 2 boys and 2 girls? Well, 3 ways to choose the girls, 55 ways to choose the boys. 3 times 55 is 55, 110, 165. That's how many ways I could choose them. And then the last question is, if I want to rank them, and this bit is for you, there's 165 ways to choose the 2 boys and 2 girls that I would send. But once I've chosen them, I've got to rank them in order. 1, 2, 3, 4. So, how many ways are there to do that? Have a think about that. We'll talk about it next lesson. I will see you then.